Hello and welcome to my video for MG number 2. You should be on worksheet MG number 2. It'll be in your upper left hand corner. Now first of all, I just want to say, if you have not watched the video for MG1 and you have not done the worksheet and the practice problems for MG number 1, I might lose you on this video because I'm going to go through this one pretty fast. So again, go back and do number 1 if you haven't done so, because otherwise it's going to look like I'm kind of going really fast and skipping some steps. Okay, so to get started, very similar to number 1, to MG number 1, but with a slight complexity to it, but not that much. On a map, Clarksville is 14 inches away from Nashville. If the scale of the map is 1 inch equals 24 miles, what is the actual distance between the two cities? So now here they don't have a clearly identifiable set of scale numbers like we did before with the parentheses, but it's still there. You just got to dig for it. Or not really, because they'll just tell you this is the scale. Some problems they'll just straight up say here's the scale. Sometimes they won't, but the idea is that you're looking for that scale, whether it's identified as scale or not. And anything that's not in the scale, well, that's part of what you're solving for. That's going to go along with your x. So again, we need to set up the ratio. And then we're going to figure out that it's miles and inches. Again, it doesn't matter if you put miles on top and inches on bottom or the other way around, as long as you stay consistent going across. I decide miles on the top, so I'm going to keep miles on the top. I put inches on the bottom, keeping inches on the bottom. That's the most important thing. I know I said this in MG1. I just can't emphasize how important this is. If you mess this up, nothing else in either video matters, because that's the easy part. This is easy too, but it's what I see people mess up. Fill in the left with the scale. Remember, that's the one we usually circle. So from the scale, and again, in your own work, and on the Casey, I would highlight or circle or something to make sure you know what's the scale and what's not. So in here, the only thing I've underlined in green is just the scale, so I don't get that mixed up with the problem numbers. 24 miles and 1 inch. And then the problem has 14 inches. And what is the actual distance between the two cities? So they're not telling us how many miles. And again, there's clues for what is the scale and what is not a scale. An equal between two problems. You know, the scale of the map is these two numbers. That's how you can figure out what your scale, what your circled half of the ratio is. I kind of already did step C, it's over there, and now we can solve, no different, it's the same thing over again. So x times 1 is x, oh, forgot to bring down the equal sign, 24 times 14. For those of you who can't do that in their head, like I can't, we'll go ahead and multiply out, so 4 times 4 is 16. 4 times 2 is 8, plus 1 is 96, and 0 and 24. So bring down the 6, 9 and 4 is 3, carry a 1, or 13, carry a 1, and 336. So 336 is the answer, and, the x was with miles. So 336 miles. I don't think you'll see a problem where they'll say 336 miles or 336 inches. Which one is it? But in case they are in a bad mood when they write the Casey this year, look at your ratio that you set up. Another reason why you want to be really organized with your notes. Don't skip out on this part thinking like, oh yeah, I just remember. Because this will remind you if they do decide to get mean, are you solving inches or miles? And that's it. That's how you solve it. The key part again is deciphering here what the scale is and what's not. So on a map, Clarksville is 14 inches away from Nashville, period. It doesn't tell you how many miles that is. That's another clue that that's not the scale. That this is part of the problem. Now we're actually going to do something a bit different and not do number 2 on the guided practice. Don't cross it out. You're going to do that independently. But I thought a better example than just doing the same kind of thing over again is go to one that has a very slight curveball, but not really. It's just a little bit different because we've been seeing a lot of 1s in the scale. Well, number 1 on the practice, so hop down over the line just to the practice below. This one is still most of the same thing, except for in the scale, you'll notice that there's a 1.5 and a 10, not just a solid 1. Some people might see that and freak out. There's no reason to. You do the same thing. It doesn't matter whether it's 37.82 equals 94.35 feet. It doesn't matter. You follow the same system. You solve it the same way. So we set up the ratio. And let's see. So this is going to be our scale. And it's easy to pick out because we got 2 numbers with an equal sign in between. So I'm going to put inches on top because that's what I'm in the mood for. And feet on the bottom. Alright, so this is going to be our scale. So 1.5 inches on top, so 1.5 goes here. 10 feet, feet's on bottom, 10 goes here. Let's look inside the problem. Miniature train was constructed using a scale of 1.5 inches equals 10 feet. If the miniature train is 6 inches tall, how long would the rail train be? Alright, so 6 inches. So inches there, and we don't have any other information. We've used all the numbers, so that's our x. And now we can solve. 6 times 10 is 60. 1.5 x times x is 1.5x. And then divide by 1.5 to get the x by itself. Divide by 1.5. So then we have 60 divided by 1.5. Can't have a decimal on the outside. We've gone over this. Decimal there. Fill in a 0, put a decimal here. 15 goes into 60 4 times. I'm doing this really fast. You might need to pause and, to finish writing your notes before I finish up. But anyways, we've gone over this in an earlier video. So if this is completely foreign to you, check your notes from an early video. That leaves a 0. Bring down the 0. Bring another 0. So that means x equals 40. And x was feet, so we're talking 40 feet. And that's it. You can go ahead and finish the rest of that whole side of the page. Do not go on to the homework problems unless I tell you otherwise. And that's it. Thank you.